Sweden's New Karolinska Solna Hospital in Stockholm is one of the largest and most advanced healthcare facilities ever conceived. Once completed, the $1.6 billion building will contain over 8,000 rooms and treat up to 1,800 patients a day. There'll be 36 operating theatres, 8 radiation units, 168 examination rooms, a research lab and numerous classrooms across some 320,000 square metres of indoor space, a floor area greater than that of the Burj Khalifa. The facility is set to be accompanied by a patient hotel, parking garage, research building and a dedicated subway station. Designed by two of Sweden's most renowned architectural practices, White and Tengbom, the project aims to be an exemplar healthcare facility, passionately pursuing a patient always first vision. All inpatients will have private rooms, with associated hygiene facilities and space for relatives. The floor plan has been optimised to reduce patient travel distances. Specialist departments are spread throughout the hospital, negating the need for patients to be transferred between departments for therapy. MRI scanners, for example, are located throughout the building rather than in one single location. Taking such a project from concept to reality is far from easy. New Karolinska Solna was designed with one of the world's most advanced mechanical and electrical installations and faced the prospect of being constructed alongside the existing operational hospital. Further, the new building was required to meet the highest technical installation standards and sought an ambitious LEED Gold certification for sustainable design. To successfully plan and deliver the scheme, the project team embraced building information modelling, making it Sweden's largest BIM project to date. Stockholm County Council, who commissioned New Karolinska Solna, required that the project be developed in a BIM environment from the outset, appointing their project team on that basis. All parties, from the architect and contractor through to mechanical and electrical engineers and the facade consultants, shared their graphical and non-graphical data within an online space known as a common data environment, hosted on a central server. Design team members exchanged their graphical model files with each other weekly, federating their component files into one model that could then be reviewed in fortnightly design coordination meetings chaired by lead contractor Skanska. These sessions enabled the hospital's design to be tested virtually before it was constructed for real out on site. Numerous hard and soft clashes were resolved, saving hundreds of hours of potential rework. The bi-weekly process was repeated until the building's proposals were well honed. Design iterations occurred faster, risks were identified and reduced, and the wider project team could complete cost and programming analysis on the data generated. Such an approach meant that almost every aspect of the scheme had been considered in advance of construction, and that the team were extremely well informed before a spade ever entered the ground. Beyond the work of the core design team, the project's graphical information model has been populated with almost 1 million objects from some 400 contributors across the supply chain. A single data standard, set out clearly in the project's BIM execution plan, has helped to ensure that information is well structured, enabling a smooth transition from construction to the operational phase. The benefits of BIM are also being felt on site, where supervisors, site managers, engineers and contractors can access the model via tablet devices. The latest and most up-to-date documentation is put into the palm of their hands in a well-ordered database, negating the risks of hard copy and the time that could be wasted searching for information, especially on a project of this scale. As if the scheme weren't complex enough, the new hospital's site can only be accessed from one of Sweden's busiest roads. Over 300,000 deliveries are expected during the construction works, and these have been planned in advance and booked in electronically using delivery management software. The system tells the driver their delivery time, the GPS coordinates of the gate they should use, and allows them to book the crane, forklift or lifting equipment needed. New Karolinska Solna is the first project in Sweden to be delivered under a public-private partnership or PPP finance model, and Skanska, along with their development partner Innisfree, will be responsible for operating the facility until 2040. As construction works complete, the project's information model will be verified and updated with as-built data as required. It will then be passed to the building's operators as an asset information model that informs lifecycle costing, optimum operation and maintenance of the live building throughout its life. The Advanced Hospital is incorporating numerous technological solutions to improve its operational efficiency. Most intriguing are perhaps the 29 Automated Guided Vehicles, or AGVs. These robots will transport goods around the hospital using dedicated passageways and elevators, freeing up time for clinical and support staff to focus on patient care. The highly automated AGVs will run around the clock, completing up to 1,600 transports every day. Whilst the final outcomes are still to be seen, the project stakeholders agree that working in a BIM environment has been indispensable to the success of such a complex project. The new Karolinska Solna Hospital is set to become a cutting-edge healthcare facility and a unique environment for world-class medical research. A significant BIM case study both for Sweden and the global construction industry. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.